This is the Nomenclature Lab. This is a quick review of naming. This section is metals with nonmetals. These aren't the transition metals. These are the two tall columns plus aluminum. We're going to name this just with the metal name and then with the nonmetal and IDE. So we say magnesium, sulfide, and potassium chloride. There's similarity in the naming when you look at metal polyatomic ions. You just say the metal's name again, like you did last time, but this time you say the polyatomic ion name as the same. So they both are the negative part of the compound. We say lithium, then we look at the polyatomic ion chart. We find that NO3 group up there has a -1 charge and it's called nitrate. We just write the name down. Nitrate, lithium nitrate. Potassium nitrate. The next category are with transition metals. There's the middle section of the periodic chart. They're the metals. They always go positive, but they can be different amounts of positive. So we need Roman numerals. Copper, we have to figure out the charge. Bromide, there's one bromine, and it's in the column that has a -1 charge. And copper has to balance it out. So if we call copper X, then we have that X -1 is equal to 0, so copper's charge is 1. Or you can just think, I need a +1 to balance out my -1 from the single bromine. The next compound is iron. Leave a space for the Roman numeral. Chloride. Chlorine has 2 atoms and they're -1 charge. The whole thing has to equal 0. So X -2 equals 0. X has to be 2. Or you can just say that you need a 2 to balance out the 2 negative chlorides. Notice it's metal with the metal "ide," same as earlier, except you also have a Roman numeral. Always use capital I's. Now for the polyatomic ions, it's iron. Leave a space for the Roman numeral. Then find CO3 in the chart. It's circled up there. And it has a -2 charge. You just say carbonate with an E on the end. The entire carbonate group has a -2 charge. There's only one carbonate group there. The whole thing has to equal 0. X -2 is 0. So iron's charge must be 2. Iron, leave a place for the Roman numeral. Look up SO3. It's sulfate. It's circled up there. It has, as a whole, a -2 charge. It equals 0. X -2 is 2. Iron 2 sulfate. Let's look at nonmetals and nonmetals. This is where both atoms are coming from the same side of the chart over there on the top right. We only use prefixes with this naming category, not any of the others. Notice there's a list of the prefixes if you need them, mono, di, tri, etc., etc. Let's go with the first one. This is carbon, and there's one oxygen, mono, so monoxide. So it still ends in "ide" like the earlier example we've done of 2 atoms. Let's jump to another one. There are 2 nitrogens, so we would say dinitrogen monoxide. You have to put the "mon" in front of it, indicating 1. For hydrates, there's always a compound on the left-hand side that you would name the way you've named any compound previously. Then there's a water and a certain number of them. For the water, we use the word hydrate, and we use these same prefixes. This is a pentahydrate. We would still put the copper sulfate, the copper 1 sulfate name in front of it. This is a tetrahydrate. This is an octahydrate. 2 nonmetals and hydrates are the only situation where you have prefixes. Let's look at acids. You have hydrogen on the top left, and you have nonmetals on the top right. We use hydro as a shortened form for hydrogen. Then you take the second element and you add ic. Previous to this point, it always been "ide," so note the difference. Chloric acid. Let's do the next example. Hydro. Sulfuric. Sometimes it feels like it should be shortened and sometimes not. You get used to which ones are which. So hydrosulfuric acid and hydrochloric acid. Let's look at the other ones. When you put a hydrogen with polyatomic ions, I think it's interesting that these kinds of acids have shorter names, but they have more elements in them. So you have to pay attention to the name of the polyatomic ion. You do not just write down the name of the polyatomic ion like you have in all other situations. You look at the ending. NO3 is a nitrate. Since it ends in ATE, it becomes nitric acid. Look at the periodic chart. ClO4 is perchlorate. And since it ends in ATE, it becomes an ic, perchloric acid. If you look at the periodic chart and the name ends in ITE, like nitrite, you add an OUS to the acid, nitrous acid. Look right here, this is chlorite, so it becomes chlorous acid.